All right, folks, we're here at lesson 41, and we start out with these model assessments. So I'm going to actually use this problem to teach a little bit so that you know what these things are. So the question here are, which of the following are model assessments? We in this class are modeling, and one of the important parts of modeling is to be able to test the model against actual data and compare it to see how well it does. So by model assessments, if you're in my section, we've been doing that from day one. We've been doing a comparison between actual and predicted. In project one, I actually made you do that because that's standard practice. So they list a bunch of things here and they ask you which one are model assessments. It's not a great question. However, we're going to go with it. And the first one I'm going to discuss is this SST down here. You're not meant to check it. It's not considered one of the right answers. However, SST is an assessment of using the mean as the model. One of the big concepts here is that the mean is a model. It's actually the worst case model. So if I have, for example, knees to elbows that cadets can do at West Point, one way I could reflect that data is by calculating the mean of the knees to elbows and saying, on average, this is how many knees to elbows a cadet can do. It is a model. And whether it's good or bad is measured by this thing called SST. SST is the sum squared total. It's not meant to be selected, but it is the error between other points in the data and the mean. That's what it is. It's the error between the data and the mean. And so it is the sum squared error of the mean, the sample mean. And it is actually a model assessment. The mean is called the null model. It's the worst case scenario. Don't check it. I'm just telling you this is the correct answer. SSE, on the other hand, is not between the data points and the mean. It's the data points and a different kind of model prediction that's not the mean. Now here this should have been a subscript 1, y1 minus y hat 1. The y hats are the predictions, the y1s are and the y2s are your data points. So let's say it was a knees to elbows and I wanted to predict knees to elbows from your max deadlift score. Let's suppose I have a model that predicts that. Well, I'd want to know how much error there is. And so I would take the actual knees to elbows and my model predicted knees to elbows and subtract them. And I square it so that some of my things aren't positive and negative and they end up canceling out and giving me zero error. So I square everything so that they're above zero. So each one of these represents error. And the sum of all these is a kind of a proxy for total error. And if it's super high, the model's not good. And if it's close to zero, on the other hand, the model is good. Usually SSE is used to compare two different models. And I have an example here that I brought up to share with you where we use that to do exactly this type of comparison. So let me share that with you. This was actually a paper I wrote with a West Point graduate I think he was number 1. If he wasn't number 1, he was number 2, and I don't know who the heck was number 1, and that's John Painter. He's coming back to the department, but he's amazing. And what he did for me is we had a new model to describe how fast you eat. So, if you look at how fast you eat, you initially eat really fast, and then you level off. So we had these new curves, but there was already curves being used in the field, and we had to compare the two against each other. And when we compared the two against each other, John Painter did exactly what you're doing here. He took his data and he used Mathematica and calculated the sum squared error between actual and predicted for both models and showed that ours was superior. And so that's how it's used. All right, keep going. So that is a model assessment. It's usually used to compare one model to the other because alone by itself, SSE doesn't mean anything because it's only relative to that model that you have. That's S1. R squared is also an assessment. What is R squared? It's 1 minus the ratio of the error in my model to the error in the worst model. The worst model is just the mean. And so it's a ratio. If this ratio is close to 1, it means that the error between the both was pretty much the same. And if they're pretty much the same, R squared is close to 0, and I'm just as well off using the average instead of some complicated model. That's what that's telling me. The closer that number is to 0, this number, it means the error in my model is pretty low. That's the way you force that down to 0. If my error is really low, the R squared is really close to 1, and that's reflective of being a good model. Usually, you have to look at all these other things. What are the other things? Well, there's sometimes I look at my model, just graph it and go, oh, that's awful. And I also have to look at the context of the problem. If I'm trying to predict, for example, belly fat is really hard to predict from outside measurements. And even though I have an R squared that might be 0.2, 0.2 is pretty far away from 1, it's really, really hard to predict belly fat. So I would say in the context of the research, I did pretty well. And so you have to look at all of these things, and they're not separate. All of these things are used at once so that we can make a decision and an argument and justification whether our model is good or not.